Today we will discuss about the simple supported beam with a point load at its midspan. There is a small difference between simple supported and cantilever beam for find out SFBM, and that is for simple supported beam it's need to find out the reaction force before starting all calculations. Cantilever beam does not carry any reaction force, but simple supported beam also carry a reaction force, both the free end. First of all, we have to take a point for which we will find out the moment. Here, if we take point A as to find out moment for this point, so we have to write down like this, that RB into L is equal to W into L by 2. That means upward moment equals to downward moments. Here upward moment equals to RB into L. It would be same or equal with downward moment. Here downward moment equals to load, downwards load W into distance L by 2. From these equations we may find out the value of RB, that is W by 2, and we also know that total reaction force equals to same with the total downward load applied on the beam. So from here also we can find out the value of RA, that is also W by 2, same with the RB. Now we will calculate the shear force at point B, C, A or a whole section. We may see from the image that shear force at B is equal to W by 2 for the reaction force, and it is being same up to point C, W by 2, and at the point C it is being downward and being negative for the downward load W. So at the C point also the shear force diagram is being negative and its value is being remaining also W by 2 and up to A point. At the A point this shear force value is W by 2. Then we are moving to the bending moment calculation. For bending moment at B, that calculation should be like that: RB into 0 is equal to 0, bending moment at the B is equal to 0, as at the B point there is a reaction force RB but there is no distance, so the BM is being 0. Now bending moment at C point, where shear force diagram change is sign, their bending moment is being maximum. So bending moment at C point, reaction force RB into the perpendicular distance L by 2 up to C, RB into L by 2, that is W by 2 into L by 2, and W into 0, that is also 0. So the value of bending moment at C equals to WL by 4. Next we are coming at point A, bending moment equals to the reaction force into perpendicular distance RB into L minus downward load W into L by 2. So the value is being 0 at point A, it's proved. And previously we discussed that for point load, first diagram will be two rectangle, one is positive and one is negative, and bending moment diagram will form a triangle which is positive.